Hey, Chemistry 12 class, Mr. Lum again, and we are going to be doing some more chemistry. The next section, 4.8. So hopefully you watched the video, the lecture video on 4.8, and it's a little bit long, it's a little bit dry, but there's a piece of information there, and you can watch me derive the formula for, and the formula is KW equals KA times KB. Okay, so in that video, I essentially derived the entire formula and how we came up with this formula. And this formula honestly needs to be memorized. It's not something that's on your data booklet or anything like that. You need to memorize it. So I show you how I derived this formula, but the reality is when it comes down to using this formula, you just need to memorize it. KW equals the acid constant times the base constant. Okay? So knowing that formula, we can kind of jump into a few things. Make sure you have your data booklet handy because that's going to be important. And yeah, so anyways, the first question actually is from the last section. It says calculate the hydronium concentration in a 0.45 molar solution of HCl. Now this, remember, it says this says HCl. This is a strong acid. So therefore, it 100% ionizes. So if it's 0.45 molar, this is the acid portion of water. So the concentration of H3O plus will also be 0.45 molar. What I should have asked in this question is calculate the OH concentration. Okay, and if we remember, H2O, well, 2H2O, the autoionization for this would be H3O plus OH minus. In other words, KW equals H3O plus times OH minus. We know what KW is. KW is 1.0 times 10 to the negative 14th equals 0.45 molar times our concentration of OH minus. So I have my calculator here. I could divide both sides by 0.45. So 1 times 10 to the minus 14. 1 times 10 to the minus 14 divided by 0.45, and that equals 2.22 times 10 to the negative 14th, and that is the concentration of our OH minus. So that would be the concentration of OH minus for the very first question. Okay, so that's a little bit of stuff from last time. Now we're going to be looking at calculating KB. So I'm just going to kind of split screen this right here. And we have our data booklet right there. So I'm going to go down, all the way down to the section for acids and bases and their Kas. So we're going to find the Kb of cyanide, or Cn minus. And there it is right there. Okay, and we see the Ka is 4.9 times 10 to the minus 10. So that's the Ka. Now, we know that our formula is Kw equals Ka times Kb. So Kw equals Ka times Kb. We know what Kw is. If we don't, we need to memorize it, because water has the kW of 1 times 10 to the negative 14. So it'll be 1.0 times 10 to the negative 14 equals Ka for the conjugate acid. So the Ka of the conjugate acid happens to be 4.9 times 10 to the negative 10, okay, times the Kb. And we don't know what the Kb, this table only tells us what Kas are, okay, and it expects you to calculate the Kbs of these things. So what I'm going to do is I have 1 times 10 to the negative 14 and 4.9 times 10 to the negative 10. So in order to find the Kb, I'm just going to move some of my calculations over here. I'm going to divide both sides by 4.9 times 10 to the negative 10. So it'll be 1.0 times 10 to the negative 14 over 4.9 times 10 to the negative 10. And that equals, it used to be that since I divide both sides by 4.9 times 10 to the negative 10, it gets rid of this 4.9, so we're just left with Kb. Okay, so in other words, if you want to rearrange your formula, you can just remember that Kb is equal to Kw over Ka. Okay, so I'm going to type this into my calculator. So I go 1 times 10 to the minus 14 divided by 4.9 times 10 to the minus 10 equals, and I get Kb is equal to 2.04 times 10 to the negative 5. There's no units because it is a K number, so KEQ, KSP, KA, KB, none of those have a unit. Okay, they're a constant. And they're just a ratio. So that's just 2.04 times 10 to the negative 5. So that's what the Kb of cyanide is. We're going to do this one right here. What is the Kb of F minus? I'm going to skip a few steps since I did all those kind of big steps before. But I look up F minus on this chart right here. There it is. We know that Kw equals Ka times Kb. Or in other words, we know that Kw over Ka equals Kb. So Kw is 1.0 times 10 to the negative 14th over Ka, 3.5 times 10 to the negative 4th equals Kb. Little divider for the top question. So Kb equals 1 times 10 to the minus 14th divided by 3.5 times 10 to the negative 4th equals 2.857, or in other words, 2.86 times 10 to the negative 11. And that's my answer. Okay, next one. What is the Kb of NO2? So we find NO2 on our thing. There it is. And the other thing I kind of glazed over too, whenever it says find the Kb of something, of NO2 or whatever, remember, we should always be looking for the bases on the base side. If you find, hypothetically, one of these things on the acid side, and you're like, no, right? We're finding the Kb of these things. So you need to be looking at the base side of everything. So we found NO2 right here. We know that Kw equals Ka times Kb. So Kw over Ka equals Kb, or in other words, 1.0 times 10 to the negative 14th over Ka of its conjugate acid, which is 4.6 times 10 to the negative 4. 4.6 times 10 to the negative 4 equals Kb. And therefore, Kb equals, type into my calculator, 1 times 10 to the negative 14 divided by 4.6. 4.6 times 10 to the negative fourth equals 2.17. And technically speaking, I guess I should only have 2 sig figs. It should be 2.2, just because these are, this is 2 sig figs. So 2.17 times 10 to the negative 11. So I should change this to be, if I was being a little better, KB equals 2.2 times 10 to the negative 11. Okay, and all of these should be technically changed to 2 sig figs. So it should be like 2.9 and just 2.0 for that one up there. So, but I'm not really concerned about sig figs right now. Okay, now here's the next question. I wrote tough question because it's going to relate back to the acid and base kind of stuff. So first off, this next one says, what is the Ka of HSO3 minus? So I'm going to find HSO3 minus. Now, here is HSO3 minus, but I'm finding the Ka of this. And this HSO3 minus is the base. So I don't want that. I need to find HSO3 minus when it's an acid. So that is not HSO3 minus, that's H2SO3. So I need to find HSO3. So here is HSO3 and it's on the acid side. So I then write down this number right here, which happens to be 1 times 10 to the negative 7. So what is the Ka of this? 1.0 times 10 to the negative 7. Okay, so that is the Ka of HSO3. Now it says, what is the Kb of HSO3? Since I'm trying to find Kb of HSO3, and we know that Kb equals Kw over Ka, Kb equals 1.0 times 10 to the negative 14 over the Ka. I do not use this number. This number we do not use because I need to find HSO3 minus when it's on the base side. So that's the one I'll be using this number right here. Okay, so now I'm going to be plugging in the conjugate acid of this thing, this HSO3. So, and remember, this is on the base side. So this is the one that I need to use. So I'm going to be putting in this number, 1.5 times 10 to the negative 2. So this is where the big mistake happens when people are trying to find the Kb's of these amphiprotic acids. So I type in Kb, 1 times 10 to the negative 14 divided by 1.5 times 10 to the negative 2 equals, and I get Kb equals 6.6666, or in other words, we'll just say 67. I know it should be 2 sig figs, so 6.7 times 10 to the negative 13. Okay. I'm just going to fix this. That looks like a weird number. So times 10 to the negative 13. Okay, now the next question says, if HSO3 was put into water, would it act as an acid or would it act as a base? And the question is why? Now, this is not from the video. So we're going to have to kind of like think about this. Now, this number up here is much, much bigger. So the Ka is much, much bigger than the Kb. So what that means is that this HSO3 will produce more H3O plus. It'll ionize more than the Kb. So the HSO3 will make more H3O plus, then it will make OH minus. Okay, because it ionizes more as an acid than it does as a base. So if you put HSO3 in water, what will it become? It will be an acid. And you can just simply kind of say, because Ka is bigger than Kb. Okay. So very similar question right here. I would highly recommend you trying to put this video on pause, and then you can kind of see me do this answer to see if you got it correct. So hopefully you'll unpause the video right now, but we'll go through it and take a look at this one right here. So first thing is we're going to, I'm just going to kind of clean some of this stuff up here so we're not distracted. So we're going to take a look at find the Ka of HCO3. So I'm going to find HCO3. Since we're finding the Ka, we'd have to be looking on the acid side. So here is HCO3, but since that's on the base side, that's not what we're looking for, but we can use that later. So here's HCO3, and it's on the acid side. Since it's on the acid side, we can write that in, and it's going to be the Ka equals 5.6 times 10 to the minus 11. Okay, now I need to find the Kb. And we know that Kb equals Kw over Ka. Or in other words, Kb equals 1.0 times 10 to the negative 14th over the Ka. Remember, this is not the Ka for when we're trying to find HCO3, the Kb of HCO3. This one is up here because we have to find HCO3 minus on the base side when it's acting as a base. So the conjugate acid Ka of that is 4.3 times 10 to the negative 7. So I'm going to write 4.3 times 10 to the negative 7. So I type into my calculator, 1 times 10 to the minus 14 divided by 4.3 times 10 to the minus 7 equals, and I get 2.3. 2.33 times 10 to the minus 8. Okay, so again, if next same question as before, if HCO3 was put in water, would it act as an acid or base? This time we have Ka is much smaller than the Kb. Okay, so since the Kb is bigger, that means when you put this in water, it will want to ionize and make, it'll want to absorb protons or take in protons from the water, leaving behind a whole bunch of OH minus. So it will be more likely to make OH minus, or it will make more OH minus than H3O plus. And so therefore, this will be base. It will be a base. And the reason why is because Kb is larger than Ka. Okay? So hopefully that makes sense. I'm going to say this in Microsoft Teams, but I feel like this video of me doing this worksheet is a better learning tool than the lecture video. The lecture video is highly focused on me deriving the formula that says Kw equals Ka times Kb. That's kind of like the focus of that video, but we don't really need to know how to derive that formula. I think it's a good skill to have of knowing how to derive that formula. However, this whole video right here of me doing this worksheet is actually using that formula. So if you want to know how to derive it, really focus on that lecture. If you just want to know how to use this kind of stuff, focus on this worksheet. And then if you understand it, try doing the quiz. If you don't, ask me, okay? And then I can try to help you, guide you through it, okay? Good luck.